Alright, welcome to 1-1, Classifying Functions, our very first section of this lesson. Now, thinking back to Algebra 1, you probably remember talking about linear functions and quadratic functions. And let's take a look at a linear function. Y equals x is the simplest form, it's called the parent form, and if I were to ask you what is the exponent when you just see an x and there's nothing written up in that top right corner, what would you say? Well, the exponent is always assumed to be 1. Now, what about for a quadratic function? That's a little easier. We actually see it there. We see that the exponent is a 2. If I were to ask you to classify an exponent of 1 or an exponent of 2, what words could you use to describe 1 and 2? Well, for the number 1, you could use the word odd. And in fact, a linear function is also something known as an odd function. Okay. And a quadratic function is something that's known as an even function. And sometimes my stylus just won't write, so if you see me rewriting some letters or writing them rather slowly, just bear with me as I figure out this technical difficulty. Now, we say that 1 is an odd number or an odd function, and I want to ask you, what are some other odd numbers? Well, there's 1, and then the very next odd number would be 3. And then the very next odd number would be 5, and then the very next odd number would be 7, and so on and so forth. And just to get to the next odd number, you would always add 2. What about an even function? What are some even numbers? Well, we have 2, and you always add 2 to get to the next even as well, so 2 plus 2 would of course give us 4. 4 plus 2 would give us 6, and 6 plus 2 would give us 8. And of course that would then continue on forever. Now notice, we're calling these things odd functions, not odd numbers, so how would you see an odd function? Well, it would look something like y equals x to the power of 3. Or it would look like y equals x to the power of 5, and so on and so forth. So if I were to ask you, is x to the 7th or y equals x to the 7th an odd function, you would say of course it is, because 7 is an odd number. Down here, for an even function, we could say that y is equal to, x to the 4th. We could say that y is equal to x to the 6th, and so on and so forth, and of course all of these would be classified as even functions. Okay, I'd ask you to pause that, finish taking down any notes, and we're going to hop over to somewhere else. And in fact, if you want to do this with me, we're going to go to Desmos graphing, and all you have to do is simply Google Desmos graphing, and I'll write it right here. Desmos graphing. And of course, that's just the word graphing. Alright, I'll see you there. Okay, so here we are at desmos.com/calculator. Now I got here by typing in Desmos graphing, but it doesn't matter how you get here so long as you are here. Now from here, I want y'all to go look at this little wrench up here where it says graph settings. One thing that I would always encourage you to do is I would ask you to change it like this. Go to here where it says minor grid lines and unclick that, and then where it says step, I just want you to put the number 1, and here, step, put the number 1 as well. And the reason I would ask you to do that is now these are going by ones, you don't have any of those confusing little minor grid lines. This should look a lot easier to look at. Now what we're going to do is we're going to explore what does an odd function look like. So here is our linear function, this one that you're very used to. And if you want to add a second graph, see how I go back over here to where I typed in y equals x. I can click enter, and I can now type in y equals x. And if you want to get an exponent, what you're going to have to do is hold down the shift button and push 6. Alright, and now for my next odd function, I'm going to put 3. And you'll notice this actually looks kind of crazy. Okay, so I'm here, I push enter, it gives me another graph, and I can push y equals x, and once again ask yourself, how do I get to an exponent? I push shift and what number? Shift and 6, very good. So shift 6, we add 2, we have 5, and there we see our next odd function, y equals x to the 5. What if I just continue doing this? Y equals x to the, y equals x to the 7, and here's y equals x to the 9. In fact, think about the craziest odd number that you can think of. Like, what's a really, really large odd number? And in fact, let's try this. Let's try something like y equals x to the 51. And of course, you'll notice they're all essentially the same. Now we're going to look at what similarities all these functions have in common very soon, but real quick, we can just click x's on all of these, and let's go ahead and take a look at some even functions. I put a shift, housetop 6, and now I put 2 for quadratic, and if you remember back to Algebra 1, we always say it has a U shape. So now we have y equals x to the, and what's the next even number after 2? Well, that would be 4. And it still has a U shape, but notice it's a little bit thicker at the bottom and it's a little bit narrower up top. Okay, what about this? To the 6th. And that trend kind of continues. How about this? Y equals x to the 8th. Yeah, and they're going to continuously look the same. Now once again, let's put a very large even number. Let's go with 80. Let's see, does it look the same? Yeah, and at the bottom it almost looks like a perfect rectangle, and you can see at the top it's incredibly thin. Well, play around with this if you would like, and I'll meet you back at our note section. Okay, so now that we looked at odd functions and their graph, let's notice a couple things. One, we can always draw ourselves an xy axis, and I want you to get really familiar with doing this. I feel like a lot of students don't like graphing just because they simply don't understand it, but graphing can be so helpful when determining solutions or long-term predictions or models. Now, we saw that a linear function looks like this, and we saw that essentially every single other odd function looks something like this. And you might think right off the bat, you might think that these things don't look anything alike, but the truth is they actually share two common properties. In fact, these are going to be the two common properties of every single odd function. So let's look at property number 1. If I were to ask you what type of symmetry, and I want you to think back to geometry, if you had geometry, what type of symmetry do these lines have? Well, it's something that we call rotational. Okay? It's called a rotational symmetry. And what is a rotational symmetry? And by the way, I'm going to abbreviate the word symmetry, just S-Y-M. So our rotational symmetry is this. Let's pick a different color. Let's say I took this red right here, and I started at the origin, and I highlighted that all in red. And I can even highlight this section in red here as well. Well, 180 degrees tells us that if I take those red sections and then I rotate them to the left by 180 degrees, and hopefully that shows up well on y'all's end. Here, let me change colors. If I rotate them by 180 degrees, well, you would actually wind up with the same thing down here. And so this left section would look exactly like that right section. It rotates on top of it. This left section of the linear line will look the exact same if we rotate that top section around it. And you can almost think of like the hands on a clock as an excellent example of rotational symmetry. Now, what's the second thing? The second thing that we're going to have to concern ourselves with? Well, this will be our domain and range. Now, this is kind of a difficult concept to tackle at the beginning of the year, but I want you to be exposed to it now, simply so you're not confused about it later, or you have some sort of base level understanding. Domain and range. And I want you to think of this word domain simply as either going to the left or going to the right, and I want you to think of this word range simply as going up or going down. Once again, stylus issues, please forgive me. Now, so our domain is going to left to right, and our range is going up or down, and here's how you do this incredibly simply. We'll say when we look at an odd function, when we are going to the left, or aka when we're going towards negative infinity, and remember this is our domain, so when our domain is going to the left or towards negative infinity, look at the graph. What do you think it's doing? As it's going to the left, you just ask yourself, is it going up or is it going down? And right now, just say it out loud. What do you think? Is it going up or is it going down? And we notice clearly this line is going down. And when you think about down, what is down? Well, down is going towards negative infinity. So we'd say for our range, when we're going to the left or negative infinity, we are going down, or aka also towards negative infinity. Now let's talk about our domain. And remember, I'm just abbreviating the word domain with the letter D. And what happens when we're going to the right? And what would you say is going to the right? Well, you notice here on the x-axis, when we're going to the right, we are going towards positive infinity. And I should have said this earlier. When you're going to the left, of course, you're going towards negative infinity. So when we're going to the right, or aka positive infinity, we would say this question to ourselves: is the line going up or is it going down? Now look at this graph. What do you think? Is it going up or is it going down? And of course, it's going up. So let's say, hey, our range, as our domain approaches positive infinity, our range is also approaching positive infinity. And here we come to our first major principle about odd functions, is that essentially whatever the left-hand behavior is doing, the domain is going towards negative infinity, well, the range will behave the same way. The range too will go towards negative infinity. And as our domain goes to the right, or positive infinity, well, our range too will go towards positive infinity. I would encourage you to pause this, finish writing down any notes. Let's go on to our even function. Okay, so here's our second and last example for this section. And let's go ahead and draw ourselves an xy axis. And let's draw all of our even functions. And notice our even functions all really look the same. Here's x squared, it was a U shape. And then when we went to x to the fourth, it got a little bit narrower, a little bit blockier. And here was x to the 80, is really blocky, and then really, really narrow at the top. So you'll notice this actually has a different type of symmetry. It doesn't have rotational symmetry, it has what we call reflectional. And it's reflectional across the y-axis. So you can think of this almost as like when you put your hands together and you fold them closed and you see all the lines on your hands almost perfectly match up. This is that same thing. So we're saying, hey, anything that we have here on the right, you can directly reflect it over here on the left, and these two things would fold perfectly on top of each other. So of course we'll call this reflectional symmetry. Now remember, I'm going to abbreviate the word symmetry, just S-Y-M, but there's our reflectional symmetry. Now let's go to the second part, and this is the part that's a little bit more tricky. Remember, we are going to talk about our domain, and we're going to talk about our range, our domain and our range. And once again, let's talk about domain when our x-axis is approaching negative infinity. Remember, going to the left is negative infinity, so we're going to the left, negative infinity. What will our range do? And look, it's as simple as asking yourself, is our range, or is the line, is it going up or is it going down? And I want you to say it out loud right now. When we go to the left, this graph is going up. Excellent job. And so we'd say, hey, since the range is going up, it is going towards positive infinity. And it's that simple. As our domain goes to the left towards negative infinity, our range goes up towards positive infinity. And you'll notice that is different from the odd function. Okay, what about when my domain is going the other direction? When it's going to the right and we're going towards positive infinity. So here we're going towards positive infinity. Well, once again, ask yourself, is this line going up or is it going down? What do you think? And of course, it's going up. And since it's going up, it is still going towards positive infinity. And so this is why even functions are a little bit different from odd functions in that they'll always go into the same direction. So if on the left, as you go towards negative infinity, your range is approaching positive infinity, well, on the right, the range will also be approaching positive infinity. They're going to be the exact same. Okay? Alright, I hope that this video helps you out. I want you to go tackle these following problems. I promise they're so easy if you just watch this video, and I'll see y'all in our next section.